Prasanth sir to give us.
So, good morning, all. Thank you, Professor Dash and Dr. Sushri, for giving that wonderful brief, and Dr. Mohanty, Registrar, Kids, and all the participants of this workshop. No, this is a very important topic. As Dr. Sushri was mentioning, machine learning in speech processing. So the speech processing itself is an area of research for a long time, more than 6, 7 decades, and the amount of work that is done in Indian languages is very limited. See, with the um, artificial intelligence becoming a disruptive technology compared to whatever we had the field of computing earlier. See, the one fundamental shift that has happened in terms of technology capability is earlier when we were developing speech technologies, we wanted to develop a human computer interaction via speech modality. So, as a result of that, the human computer interaction when we are doing earlier, we are all developing speech modalities by keeping in mind that no, we are trying to interact with a computer, and to develop technologies for that, you need um, awareness and some level of literacy with reference to using the computers. Whereas with the help of artificial intelligence, now the tables have turned. Where the artificial intelligence, with its improved ability, what is happening is um, this disruptive technology is able to give much more capabilities compared to a simple computing that we were doing. Um, so the capability that it is giving is the earlier, whatever the struggle we used to do to build speech technologies when we want to interact with computers, now that struggle technology has to do and worry about how to facilitate humans. So the human computer interaction, now it is turned towards computer interacting with the humans. In the sense, whatever the struggle we used to do for interacting with computers, and we are doing a very cooperative movement with the computer. Now computers have to do a cooperative movement with the humans to interact. That means to say, all that struggle, difficulties of interacting with humans by the computers has to be taken by the computers, and that is enabled by the artificial intelligence. So when we do that, what happens is there are several advantages for the development of new speech technologies. See, earlier we used to worry, I don't have resources for a tribal language. How do I develop speech technology? For English, there is a lot of resources. Oh, I can easily develop technology. So now what is happening is, and we when we are developing speech technology, we kept a lot of resources from the written form of the language. Now, when we come to tribal languages, there are no written scripts available. So, in that case, how do I deal with that? This itself were research challenges. Now, with the ability of AI, artificial intelligence, see, if you consider two people from the same tribal community talking to each other and exchanging the information, even though they are not formally having a written script for that language. Okay, and the same ability now we can give for the computers when they are interacting with the machines. So, sorry, when they are interacting with the humans, and that is where the golden opportunity lies. And the second, as a result of this, the second important point is we don't the this the first advantage I told this, and the second advantage is when we are developing such technologies, we have to come out of the approach that we were doing traditionally for speech processing, where suppose if I consider human communication, um, as long as my fellow participant in the communication is able to understand what I am telling, there can be disfluencies, my I may be mispronouncing a word, or I may not be having a grammatically phrase may not be correct, and so many other things are there. With that, if I'm able to communicate, and that is a different ball game altogether. That's what humans do on a daily basis, compared to a structured written form of the language. Okay, so the existing speech technologies have borrowed significantly from the knowledge of written form of the language, but now we have a ability that I don't have to worry about the written form of the language. I can directly develop capability for computer to hear your speech and respond in speech. That automatic speech recognition is there and speech synthesis is there. With that, we can do. And now people are not worried about no converting speech into formal text and check whether text is proper or not. What is that ASR challenge? Now people are talking about how do I move from speech to meaning or semantics directly. Okay, as long as the meaning is conveyed, I don't care about the other aspects. So that is how the whole world is moving, and this is also a golden opportunity for us to develop technologies for all the languages of India, including tribal languages and maybe other languages across the world, because I don't require that type of struggle that we were doing earlier. So I think that's a ray of hope with the artificial intelligence, and I hope no many interesting talks have been scheduled. I'm sure they're all exciting, and all the participants who are attending kindly take benefit of that. And I sincerely thank KIT for and Professor Dash for organizing this interesting workshop. I'm sure many of the participants will get benefited and try to participate and continue their research journey in the exciting field of speech processing. And thank you all. I wish you all the best. Professor Das, I have a meeting to leave.
Okay, sir. Thank you. Thank you, sir.
Thank you, Dr.
Thank you very
Sushi.
much.
Thank you, Dr. Mohanty. Thank you.
So now I will request our own register, Dr. Gyanaranjan Mahanti. Gyana sir, kindly grace the occasion.
So, namaskar, very good morning to all of you. Respected chief guest, Professor S.R. Mahadev Prasanna sir, the director IIT Dharwad, respected Dr. Sushri Sangeeta Mahanti, director R&D at International Institute of Inclusive Museum Australia, all the distinguished speakers, resource persons of this workshop, our esteemed faculty members of different schools of our university, as well as the faculty member of School of Computer Applications, and all the esteemed delegates, participants of this workshop. So on behalf of KIT University, on behalf of our Honorable Founder, Professor Dr. Chusama, I extend a heartfelt welcome to all our esteemed guests, both our chief guest, Dr. Prasanna and Dr. Sushi, for gracing the occasion, as well as I welcome all the listeners participants for joining this 5-day workshop on machine learning in speech processing. At the outset, I'd like to congratulate the organizers, especially led by the Dean School of Computer Application, Professor Satyaranjan Das, for planning this important workshop on a highly relevant and ever-growing theme that is shaping the future of technology and communication. We all know, as already speak by our chief guest and guest of honor, that machine learning and speech processing are become an important part of our daily lives, from voice assistants like Siri, Alexa, to speech to text systems. So language translation, you say virtual customer support, healthcare applications, and there are so many smart education tools. So these speech technology are transforming the way humans interact with machines. And as said by our chief guest, that in other way you can say now computer interacting human. So machine learning in speech processing combines artificial intelligence with human language and voice analysis. It helps computers understand, recognize, and respond to human speech more accurately and naturally. This field has applications in different areas: healthcare, education, banking, you say, security systems, assistive technology for different able persons, smart devices, and many other areas. And to understand, the main objective of this workshop is to provide the participants with both theoretical understanding as well as practical exposure to modern techniques in speech processing and machine learning. I'm sure it will help the students, the researchers who are here, who have participated, to learn about recent developments, tools, algorithms, and real-world applications in this exciting in this field. And I'm sure this workshop will help participants to improve their technical knowledge, research skills, and problem-solving abilities. And the knowledge shared here will not only benefit the individual learners, but also strengthen the, I can say, the larger academic group and the research community. And I'm confident that the expertise and the experience of the resource persons who are coming from very premier institutes and industry will greatly enrich the understanding and make this workshop meaningful, engaging, and impactful for every participant. Friends, KIT University and the School of Computer Application is proud to host this important academic program. KIT University is a multidisciplinary university known for its academic excellence, innovation, research, and global outlook. It offers a wide range of programs, 250 plus programs in different areas, starting from engineering to humanities, medical to management. And this university having a vibrant academic environment with world-class infrastructure. And also it has developed a strong ecosystem for research and innovation with advanced laboratories, computing facilities, rich learning resources, and also dedicated faculty member. Because within a very short span of only just 22 to 23 years of this university is having very national and international rankings, accreditations, achievements, and accolades, including in NAAC A++ ranking, NRF we are 17th ranking, and also Times Higher Education World University ranking. In our global ranking, we are in the cohort of 501, and in Asia we are in 169th position, and in India 5th position. So these achievements reflect our continuous commitment to excellence in academics, in research, innovation, and in other activities like sports and other personality development. And this kid's remarkable journey has been guided by the vision and leadership of our honorable founder, Professor Dr. Achyut Samanth, who is a renowned educationist and social reformer. It's believed that education can transform our society, and under his guidance, KIT has earned all these recognitions for quality education, social inclusion, and holistic development. So I once again thank all the participants for joining here, for being part of these important initiatives, who are joining from all over the world, as mentioned by Professor Das. So friends, your willingness to learn, adopt and innovate will not only shape your future, it also contribute to the progress of our society. I wish a very engaging workshop. So once again, I welcome all of you. So thank you. Namaskar.
Thank you, sir. Thank you very much, sir, Sushi Madam and Prasanth sir for joining this session. Now our session will be started at 10 o'clock. Dr. Madhusudan Singh is going to take the session. Thank you very much, sir. So I think all of you can stay, or we can start the session at exactly at 10 o'clock. You can take a break, fine, and join soon at 9:55, so that exactly at 10 o'clock we can start the session. So requesting all of you to join and try to learn something, especially for from the students from KIT and the students from outside India also. Like I told you, around 72 students are joined outside India, those who are not the student of KIT. So try to learn, and if you can learn something, then we can collaborate with all the 16 distinct resource persons who are from industry and IITs and NITs. So those who are the pioneer in the field of speech processing, so definitely you can collaborate. And I will request all of my faculty colleagues, if you really working on speech processing or you want to start some work on the speech processing, definitely you just join all the sessions, try to join all the sessions and try to learn something, so that with the help of our students, because very good students are there. Okay, so by the help of them, we can have some collaborative work. We can take the guidance of the resource person who have already joined and given their consent to take all the sessions. So thank you very much. So I think just after 5 minutes we can start. You can stay here, no problem. After 5 minutes you can start. Thank you, Suru. And at any point of time, you can interact with the resource persons. You can have all the mail ID you can avail in net also, and you can directly connect to them, or through me also you can connect to them. As I told that we have a great resources available in KIT, because if you take the rich languages like your Spanish, French, Italian, so many work has already been done. But as I told by Prasanth sir, very less work has done on speech and NLP in our India. Okay, as in KIT itself or in KIS itself, we have 64 different tribal languages students are available, and number is huge, 30 to 40,000 students. If we can conduct some workshop like things, we can collect the data, and that data is not available anywhere in the world, because we have that data, we can collect the data. And along with that one, we have, as you know, more than 2,000 foreign students are available, okay, of different countries, especially from African countries. Around 15, 16 country students are available. The number is like 1,500, like that. So if you are going to use them in our work, then we can have a very rich repository, because machine learning means what? We have to train the machine, and for that one data is required. From where we will get the data? And we will get the data from our students, and they are also going to be involved, how they are going to pre-process those things, okay, and how they are going to train those things. For that one, resource persons are there from very reputed institute, that they are working in that particular field for the last 10 to 15 years. So definitely, I will ask the students, kindly join, listen. Any particular sessions you are going to miss, every day, whatever things is going to be covered, all the sessions video is going to be uploaded in YouTube, and that the link is going to be shared to you. You just go to that one, and in every sessions you have hands-on. If you will go for the theoretical things only, you can get lots of videos in YouTube. You can, but along with the theories, hands-ons are there. They are going to tell you what are the different tools you are going to use, okay, how to train those things. So definitely you can learn from them. So if we'll go through the videos after the session also and start doing something, then they are there to help you, because you have to develop something. Okay, then only, because nowadays, see, everywhere AI, machine learning, without that one, LLM, generative AI, everything is that. Without that one, we cannot go anywhere. So try to learn. It is not so easy to contact them, because all they are busy in their work. They have lots of projects are there. So it's very difficult for my parts. And one of my friend who is there in Finland, he helped me a lot to convince sir, yes, just take one session. Okay, so we have the golden opportunity to listen all of the from all the resource persons. Okay, so I think. Yeah, sir, how long will the technical? Yes, every day we have 3 sessions are there, 10 to 11:30, 12 to 1:30, and 3 to 4:30. So for the next 5 days, we have every day 3 sessions are there, and try to attend those sessions. In case you are not attending, that means you can go through the video. Not like a video is available. I'll go through the videos and I'll learn everything. No, you show that there are interaction required, at least for the student point of view. So hope for the good sessions ahead for the next 5 days. And don't worry for the certificate. If you are going to join only for the certificate, to everyone who was registered, I will give the certificate. But that certificate, that is not a great big thing. Okay, Samudra Vijay sir, namaskar. Thank you, sir. So just now, sir, Prasanth sir just now completed. So we have with us Dr. Samudra Vijay sir from KL University, who is also one of the pioneers in speech processing. Samudra Vijay sir, now sessions will be start by Dr. Madhusudan Singh sir. Thank you, sir. So now, Madhusudan sir, have you joined? So let me contact him so that he can take the session. Just wait for it. Yes, Madhusudan, let me make you co-host so that you can share the screen. Yes. So kindly,
Okay.
sir, on your video so that I can make you the co-host. Just a minute. Yes, sir. Sir, can you share your screen? Just try to share your screen.
Okay, sir. I will check it out.
Yes, sir, it's coming.
It's coming?
Yes, sir.
Okay, sir. Thank you very much, sir.
Thank you, sir, Madhu sir. So,
Okay.
working as a professor, assistant professor in NIT Laganan, he has lots of experience. So he's going to take the first session today. So any doubt, you can at last you can ask the question, or in the chat just give your query so that sir can give the answer. Sir, thank you, sir, for joining us, and just your session is yours. You can start the session.
Okay, sir. Thank you very much, sir, for giving the. Sir, I am audible, sir. Now.
Yes,
fully
yes, sir.
audible?
Yes, sir. You are very clear.
Okay, sir. Thank you very much, sir, for organizing such a nice thing. And thank you very much for giving opportunity me to serve as a expert resource person on this one. So I have also have chance to present my work also in the big platform. So good morning to all the persons who have joined this training seminar, and faculties, students, and our respected professors, renowned professors. For all, I am just telling the good morning to all. So with this, I am starting my presentation. So actually means like in this works 5-day workshop for this first session, I will represent the replay attack and countermeasures, fundamentals, and what is the use of these things and why required to develop the countermeasure and what is replay attack and why it is important from the automatic speaker verification context. So I am Dr. Madhusudan Singh, Department of Electronics and Communication Engineering, working since last 10 years and in the Institute of Technology, Nagaland. So my presentation outlines are, I will give the first that what is automatic speaker verification system, basic concept and challenges, and then spoofing attacks and common types, introduction to replay attacks, countermeasures, development of replay attack detections, excitation source features and its importance in replay speech detection contest, exploring LP residual as excitation source feature in replay detection. Just 1 minute, let me close my video. Maybe it will affect the speed. So,
Yes, sir. Yes, sir.
yes, okay. Okay, so now in this way, I will go through the then summary and future directions and then references. So, what is actually the automatic speaker verification system? So, it is a task of verifying the claimed identity of an unknown person by using speaker specific information available in his or her speech samples. So, speaker verification takes in two places, two phases. So first is the enrollment phase, other is the verification phase. In enrollment phase, we have the means we have the just collect the data of speech people, speech data of the people, and then accordingly we make the models and stored in our system for each speakers. And in the testing page, we just as we see, we will just take the test sample and we will just analyze this test sample and we will match with the voice print of the stored speaker model, and accordingly your automatic speaker verification system will give either accept or reject of the identity. So this is actually a type of key we are using our speech as a identity verification system. So and very this is very easy because giving a speech sample is very easy in any is any time. So that's why we are using this one. But now the ASB system decision in the form of accept or reject, and depend on this is has two types of errors. False acceptance means like anyhow ASB system is a machine, so definitely we can expect that there will be the errors. So sometime what happened any imposter means can be accepted as a genuine speaker, and maybe a genuine speaker is rejected as an imposter. So this is the two types of error are there. So accordingly, definitely we have we need ideally these two errors should be as minimum as possible, so that and where these two errors are equal, actually that is the equal error rate point and used for ASB performance matrix. It means that a smaller value of EER represent better speaker verification performance. So if our machine is as close as EER is very less and close to zero, definitely our machine is best. So nowadays, in the era of the X vectors and deep learning framework, now our speaker verification systems becomes advanced, and they are now really in many applications we are using them. They are practically they can eligible for deployment. So just like a smartphone unlocking, telephone banking, even Google, Alexa, many voice assistant systems are there based on the speech-based authentication system. But the main problem is that as we have the advancedness in the automatic speaker verification system, the reliability of the ASB system is a serious concern is the presence of spoofing attacks, especially for the high security application. Means still we have to think 2-3 times whether this speech-based authentication system can be deployed for the high security application like defense application or not, because there are some chances that maybe people can impersonate you and they can break the security system of the high security application. So because of that they it like active area of research in parallel with the as we are moving more and more advanced automatic speaker verification system. In parallel, there is always a development of countermeasure system to just protect our speaker verification system from the spoofing attacks or some type of fraud attempts for high security application. Both the research are going in parallel and actively in the among the speech research community. So in that way, just I want to tell you what actually is spoofing attack and common type, which is a serious concern for the automatic speaker verification system deployment for the practical use. So a spoofing attack is generally a method of altering AFD system decision using false oblique fake speech sample of a genuine speaker for unauthorized access. Now you just understand that unauthorized access actually. So mainly the purpose of the spoofing attack, we just want to get the unauthorized access of a system, which is speech, which takes the speech sample as input for verification or authentication. So there are commonly impersonation is a type of a spoofing attack, replay, voice conversion, speech synthesis. Now the recents are the audio deepfakes are available now, which are very much used for the uh, identity just manipulation or impersonation. So in that way, I am just going through one line on this thing. So impersonation is a technique where an imposter himself sound like a target speaker through voice mimicry. So it is also an important aspect, but there is one drawback is that people only they practice about the public figures only for through voice mimicry. So very little chances that anyone can use the impersonation technique to just deceive the ASB system decision for unauthorized access. Speech synthesis, speech synthesis generate the artificial text speech for a given input text. Voice conversion technique converts the imposter voice characteristics toward the target voice. And audio defects is commonly AI generated synthetic speech that mimics the real voices. So these three, speech synthesis, voice conversion, and use of both to generate the audio defect, these three are almost this time very means serious concern in the public to because they are of high use for making for positive aspects also, but they have the negative impact also when we are concerning about the security of the ASB system. So, and one more thing is that key specific voice conversion audio deepfakes are high technology attacks as compared to replay attack. So, very much research is going on this area also, but still, I just focused my the presentation under this topic on the replay attack only. So, just I want to tell why in the era of the deep fakes and voice conversion and high technology voice conversion systems are available. Still, why I just want to focus on the replay attack. So I will tell you the reason in the coming slides. So what is just before that, I just wanted to you introduce what is replay attack actually. So replay attack involves the presentation of the pre-recorded target speaker's speech sample through a playback device in front of the ASB system. So in that way, ASB replay attacks are generally known as low technology attacks because they requires only high quality recording and playback device. A layman can also do this one. For this, no, it is not required to know the much speech signal processing theory to implement it on the ASB system to for unauthorized access, and easy to implement and effective. Even one diagram I have shown in this figure, just so to in a fair situation, any target speaker or maybe some person will go and he will provide his natural speech sample or bona fide speech to ASB systems, and finally, accordingly, it will be accepted or rejected by the ASB system. If the person is genuine, definitely it will be mostly it will be accepted by the system. If it is imposter, then it will be rejected by the system in most of the time. So, but the problem when problem is come, suppose if some person who has some intention, maybe he has surreptitiously recorded your voice or maybe he get your voice, because now many people are very much popular in YouTube. They are telling something, means they are uploading videos. So now getting the voice is easy task. Before that, it is surreptitiously we have to uh, um, collect, but now the people have the so many online sources also to collect the voice of any person to whom we are targeting, and we just record that voice and we can play back in front of the ASB system, and maybe we can breach the security of the ASB system, and we can get the unauthorized access of the system. So definitely, suppose for common use, not a problem, but like for ATM, automatic teller machine, where we want to receive the money, there if speech-based authentication systems are there are high chances so that anyone can use your voice sample to just collect the money from your account. So that is the problem. And another problem that suppose in defense application, definitely that can be a very serious concern. So in that way, and also recording and playback device are also, as the technology increasing, we are getting the very good facilities in the recording and playback device machines. Means they are noise cancellation facility. They are improving. Suppose if noise is added, they are just cancelling the noise, and they are improving the quality of the voice. Even you will naturally speak, whatever natural you will speak, your your replayed voice will be more better than that type of devices are available now. So because of that, I am thinking replay attack is also not like a obsolete thing. Definitely still it has the effectiveness and can be affect the market of the ASB system. So in that way, I have just focused today's presentation research on replay attack and talk about this one. So, means definitely, finally, there is a need of the countermeasure development for the replay attack detection system. Since last 10 to 15 years, so many research has been done already, and even the standard publicly available databases also we have on that, like ASB Spoke 2017, ASB Spoke 2019, even ASB Spoke 2021. Also, we have the replay attacks data samples. So what is actually countermeasure? So countermeasure means like just we to identify and reject the spoofing trials presented to ASB system for unauthorized access. As per our previous diagram, you can see, suppose if we have the countermeasure system before the ASB system, so it will just the work of the countermeasure system to identify whether a speech is coming from the natural person or a person who is in person here, or it is coming from some device. So depending upon that, it will either accept or reject. If suppose accepted, it will forward it to the speaker verification system. But if not, then it will be reject from that place only. So that person cannot, unauthorized person cannot get the access to the system. So this anyhow, then like ASB system, this also have a decision very simple, either in the form of accept or reject. Depending and based on that, it also has like ASB system two types of errors: false acceptance, where the replay speech sample is accepted at a bona fide, and false rejection, where bona fide speech sample is rejected as speech replay speech sample. So definitely EER can be like ASB system. EER can also be used here as a performance matrix for the countermeasure system, and it is used popularly. It is used today also. People are using for the showing the countermeasure performance, and means like if like ASB system, a low EER, a smaller value of EER represent the better countermeasure system. So now we will talk about the system, because countermeasure development we have to do. Definitely we have to know, okay, what is the actually we need to develop the countermeasure, and what we actually model to identify or discriminate between the natural speech and replay speech, bona fide speech and replay speech signal. So replay speech generation mechanism involves device, microphone and loudspeaker setup. Obviously, it is required because without recording and playback device, you cannot able to present the another's voice to the ASB system. So obviously, device characteristic in the form of distortion are embedded in the replay signal, and hence the only information for discrimination. discrimination between the actual samples and replay samples. And next point is like noise from the surroundings is also a key factor, because definitely anywhere if we are just presenting our sample, definitely surrounding voice will be come into pictures, like reverberation of the rooms also, and reverberation of the system where room where the system is present, authentication system is present. So that also can those also can distort the signal up to a great extent. So in that way, countermeasure development objective is to capture public model such distortion caused by the device characteristics or surroundings, to discriminate between the bona fide and replay speech cycle. That is the objective of the countermeasure development, adopted by the adopted by the speech researchers who are working in the countermeasure development area. So now there are means like as per literature I have gone through, there are in literature two types of generally works are available. What I observe, one is the feature level approach and another is the deep learning approach. So feature level approach mostly involve the speech-based features or LP residual-based excitation source features. So we will in this presentation mainly I will discuss about the feature level approaches, and not the deep learning approaches. So in feature level approaches, I have tabulated some of the work which are rigorously done in the literature, available in the literature. So these are the works, some high frequency septal coefficient scattering feature, constant Q transform feature. There are so many features. So that is not much important. Important is that you see the third line, equal error rate, performance of the countermeasure. So I have arranged in the ascending order. So finally, and these are on the standard database, ASB 2017 database. So finally, we have seen that continuously people are working and their attempt is always successful. One by one, bit by bit, they are coming down, and finally up to whatever I have seen, as per my knowledge, 6.40 is still the minimum equal error rate on the ASB 2017 database. That is CMH feature, it's like a neural network feature. So that is giving the best result of 6.40% a year this time. I mean, as per my knowledge, this is the best result get by the author in ASB 2017 database. All are speech. So just feature level approaches also, I have discriminated the feature level approaches into two parts. One is speech-based feature. Speech-based feature means like where the people are using speech as a input and they process the speech signal and get the model some features which are able to capture the some characteristic of the replay signals, and accordingly they are giving the performance. And one is LP residual. LP residual is also not new. It is also another component of the speech signal derived from the speech, but it has a significant. It has another type of importance because it is just like a part of the whole speech signal, and that is very important also. So this is and we called as a excitation source features mainly. I will discuss later on what is actually this one. So now this performance I am showing that some of the people who have work in LP residual based excitation source features on ASB 2017 database. So what we have seen, there is a all the description of these work, whatever I have presented, you can found in review paper, this one. And we have seen in this table, we can see that LP residual based excitation source features are working good, but is still and continuously reducing. But still there should be, what I am thinking, that there is a chance that 14.03 is the last number that can be again made down and down if we work more and we can exploit more using alternative signal processing. So what we have that there is a research gap. We can see that in wide exploration of excitation source feature is still not in practice. People are not practicing the excitation source characteristics actually for doing the research either in any area, even in spoofing also. Most of the people, they have switched to deep learning framework and they are applying the speech signal or maybe directly speech input to the deep learning framework, and they are getting the good outputs also. No doubt that we are getting the good output on that, but generalization cannot be still against unseen attack is still is in question for those systems also. So maybe because of the one reason that they are not able to capture the differences of the unseen attacks, so that and maybe quality of the recording replay recording produced by the advanced quality device, that may be a reason. So in that way but anyhow, for me, that I feel that maybe there is a less exploration on this one. Might be there is a chance that we will get the better generalization and good result using the excitation source feature. No doubt standalone they will not work, because as we have seen on the theory of the automatic speaker verification systems and past experience, excitation source are work good. They can help but they are not bypass the performance of the speech based feature, but definitely both are have the complementary nature. So definitely if we will combine both of them together, we will get definitely some generalization concept under unseen attacks or unknown attacks situations. So in that way, just I will discuss some excitation source features and its importance in replay speech detection context. So first of all, just I want to actually just make to familiar you with the excitation source feature. So for that, human speech is produced through a source filter interaction, where the air from the lungs drives vocal fold vibration, the source, which we call as a source, to create a buzzing sound, which is then saved by the resonance of the vocal tract, the filter, which we call as a filter, like our oral cavity, nasal cavity, and mouth and lips. They just make as a filter to produce the distinct speech sound. So that whatever the sound, whatever the noise kind of thing that created due to air pulses from the vocal fold vibration, that are actually saved by the vocal tract, our nasal cavity, vocal cavity, and lips to produce the different type of sounds, different frequency of sound. So this is actually so in particular we have two things. One is the vocal tract filter and one is our vocal tract, means like vocal fold vibrations in the glottis. So glottis is one thing and our mouth, oral cavity, nasal cavity is another thing. So source filter interaction. So that vocal fold vibration, our glottis, that is actually measure of the excitation source feature. Actually, we are just wanted to use that vibrations of that one, characteristics of the vocal fold vibration separately for detecting the replay speech signal. So in terms of popular LP model, linear prediction model, the actual speech signal is represented as Sn is equal to escape n plus Rn, where escape n is this k is equal to 1 to p ak Sn minus k, where p is the order of the prediction. Here escape n models the vocal tract component of the actual speech signal in terms of LP coefficient, which is also called as a filter coefficient. And LP residual signal represent the corresponding excitation component, that is the vocal fold vibration or glottal flow, we can say glottal flow signal it represented. So in signal processing aspect, the replay signal can be considered as a convolution of the actual speech signal and playback device response as given by this one. So it implies if you will put this Sn in component, so finally from the fifth equation we can get that key vocal tract filter vocal tract component is also affected by the playback device response, and our excitation source component is also affected by the impulse response of our playback device systems or device assembly, replay device assembly. So in that way we can say that equation 5 shows that the excitation source component can also be useful and we can use it to develop the countermeasure system, because definitely the excitation source component is also affected, and that whatever the change is there, that change we can capture and we can use it for the discrimination between the actual and replay space signals. One of the key point. So replay means again I just seen what is the effect of play, how playback device response, impulse response can affect the signal that we have just seen, how it is going to help that excitation source we help us that whether excitation source is affected or not. So in that way, just I have kept here in figure 3, there is a typical frequency response of a high quality smartphone loudspeakers. I have seen, so I have shown. So luckily I get that the range is also 0 to 4000 hertz, means like this is the total pure speech range, means our audio is also in this range only. So what I have seen that replay speech is generated from the bona fide speech which is passed through the recording and playback device assembly. Playback device response into induced distortion in the replay signal. Definitely, this is the impulse response. So at different frequencies, the response or impulse response of the playback device is different. So what we have seen below 500 hertz, we can see that the impulse response is very low. It is suddenly drop. There is a drop in there. So definitely, when some speech signal will pass through, definitely below 500 or speech signal will be affected very much more, or attenuated, distorted below 500. So 0 to 500 hertz, I have seen that this is the key point. And also I can tell means like their fundamental 0 to 300 500 hertz, there is always fundamental frequency of either male or female. They are about 200 to 200 hertz range. So definitely the fundamental frequency is affected here. And strength of excitation is associated with the fundamental, that is also affected in this place. So in that way, we just I just somewhat came to know that maybe excitation source is affected by seeing the characteristics of this loudspeaker. Now, second point, what then after that, what I think that okay, I will go through another level of experiment to just see whether it is there or not for the practical loudspeaker. So what I have taken 5 loudspeakers. One loudspeaker, this P note is actually my means like we have created. It is ours. We have means this P4, P5, P7, P9. They are the loudspeaker which are already available in ASB 2017 database. So I have taken these loudspeaker sample, 10 samples, 10 utterances, real recordings and playback recordings, which is generated from these loudspeakers from the ASB 2017 exam to maintain the standard of this calculation. And then I have taken the P note, that is Creative SBS A35 desktop loudspeaker. So I have just recorded and replay back my own voice and my research group participants' voice, and I have collected the 10 samples, 10 original and 10 playback through this device P note. And then I have in a different frequency band, 0 to 300 hertz, where the fundamental frequency and everything lies, then 300 to 1000 hertz, then 1 to 2 kilohertz, then 2 to 4 kilohertz. I have just calculated the spectral distortion between the actual and replay signal. For spectral distortion corresponds to the average root mean square log spectral difference between the two recordings, means actual recording and replay recording, and it is computed from the standard short-term spectral analysis using Hamming window of 20 millisecond duration and 10 millisecond overlap. Average why I am telling, because I have not taken one sample. For every loudspeakers I have collected 10 samples, so that at least to make the result more commonly to analyze whether it is definitely affecting or not. So what I have seen, distortion is every place is there, but in the low frequency region, 0 to 300 distortion is coming high, whatever in this band. So just I confirm that maybe below 500 hertz the loudspeakers are affecting. After that, I went to the theoretical aspect again, ki why actually response is coming like that, why low frequency are more distorted. So I just came to know in the literature that ki loudspeakers actually they because of their loudspeaker diaphragms inertia to produce the low frequency component, they have to move more up and down, move up and they have to travel more. So because of that, because of the inertia, they cannot able to do that. So that's why they cannot able to move more, because just to produce the low frequency, the diaphragm has to take the bigger what we can say, um, they have to move more distance, and that cannot be possible. So because of that, distortion takes place while producing the low frequency component of the speech signal by the loudspeaker. So then I just confirm that maybe it is expected that low frequency components are definitely low. This loudspeaker components is affecting the low frequency components of the speech signal, especially below 500 hertz or 0 to 300 hertz. So fundamental frequency is also coming in that one. So definitely fundamental frequency is disturbing, means their harmonics which are spread throughout the entire spectrum, that is also going to affect. So in that way, definitely loudspeaker is creating the distortion in the excitation source information. So with this conclusion, I just again go ahead with my some another level of experimentation. So I have seen that what I have taken speech segment and LP residual signal from the actual signal and its replay counterpart, actual speech signal replay counterpart, LP residual obtained from the speech signal using LP analysis, and then LP residual, LP residual of the replay signal, and then LP spectra, LP residual spectra, which I have showing here. So what I have seen that that LP spectrum level, when I have seen in the low frequency region again. Here, the formats are almost remain intact. No, it's looking somewhat similar only. But here, I have somewhat seen the difference. In low frequency region, some attenuation is there in LP residual spectra. So I think might be it will work out to use the LP residual spectrum to LP residual spectrum parameterization as excitation source feature for replay attack detection. So in that way, now exploring LP. So just this is the theory, whatever I am telling behind this one, this figure, just. So in that way, finally, what we conclude that from this type, these observations from the 2-3 figures and this one, even one spectrogram is also, if you will see, is spectrogram level also there is a difference. That slide I have not added, but that is also will show that LP residual parameterization and excitation source feature may be useful for replay detection tab, because there is also the LP residual spectrograms are also distinct for the actual signal and replay signal. So finally, one kind of so for just to check whether it is working or not, one type of parameterization, the simple and easy traditional, that is the male representation of LP residual referred as residual male frequency septal coefficient, I have used for generating the countermeasure system or RMFCC based replay attack detection systems. So so I have just experimented that performance, and I have seen this result. I have quoted with the SBSPOOF 2017 database only I have used. So what I have seen that I am getting a performance of 20.88. It bypassing the MFCC feature, but it doesn't bypass the speech-based MFCC feature and CQCC feature. But what I observed that whatever the result the speech-based features are giving, and they are still struggling, and there is a problem in generalization. So what I just fuse the excitation source feature with this, because excitation is different, and if they are whatever past experience I have the from automatic speaker verification works which are related to excitation source, I have seen that excitation source works are giving the result, good result, but when they are combined with the speech-based feature like MFC, something performance is improved. So from there, it is proved that there is if LP residual based features have the complementary information, or in other words, we can say excitation source features have the complementary information as compared to speech signal. So when they fuse, definitely we will get the improved performance, and that is definitely better for a generalization of the system, because one feature, just relying on only one feature, maybe it's not a good decision, because maybe one feature will work for one type of database, but another type of database might be it will miss some of the important aspect. And but if 2 3 features will be there, definitely everyone will keep their own aspects, so at least complementary wise we can get the better results. So I have seen that improvement is there. MFCC from 22, it's came to 16.80, almost 6% EAR reduction. And CQCC is also C, more than 6. It came to single digit, 9. They are double digit EAR, but performance is single digit EAR. So in that way, just we think that there is a importance of the LB residual signal also can be used for the replay attack detection task. And then I went, okay, maybe definitely this will not be the only result. We have not to stop here, because we have to improve more and more, and we have to make close to 0. So for that purpose, I went again the LP residual based alternative feature. So what I did, I see that LP residual RMFCC feature is actually computed from the magnitude spectrum of the LP residual. So I think why not the phase information also, which is associated with the LP residual signal, can be used. So the playback, and also I have seen that we just analyzed the theory, maybe playback devices, they involve the chain of the transformation, because RC filter, definitely register capacitance components are there. So definitely might be when original speech is passes through the playback device systems, definitely while producing the replay speech, it will undergo through the chain of transformation, and might be phase will also change because of the RC components available in the replay devices, replay setup assembly. So replay device setup assembly. So analytical representation of the LP residual provides us amplitude, that is we called as a Hilbert envelope, and phase information residual phase of the LP residual signal separately. So what I did, I have taken the analytical representation of the LP residual to just use the phase information for replay attack detection task, which is available in the NP residual, raw LP residual signal. So I will show the diagram, actually what we can say. So this is the actual signal and replay signal, and these are the corresponding LP residual signals. Now I have divided these things into the Hilbert envelope, the magnitude component of this LP residual signal, and phase. This is the residual phase. Means now this diagram of the LP residual signal, which has the magnitude and phase here in the raw LP residual signal. Now I have separated the magnitude component, which is which I have written as a Hilbert envelope, and phase component. So the magnitude and phase components are now separately represented by the Hilbert envelope of the LP residual and residual phase of the signal. Now what I did, I have instead of parameterizing the LP residual, direct parameterizing raw LP residual, now I have parameterized the Hilbert envelope of the LP residual and residual phase of the LP residual, which is obtained from the LP residual signal. So in that way, I have referred them as a RHMFCC residual residual Hilbert male frequency septal coefficient, residual phase male frequency septal coefficient. These two components came. One is representing magnitude and one is representing phase. So what I have seen, they are the 23.6 point equal error rate and RPMFCC phase component given the good result. Even it outperformed the original raw LP residual based RMFCC feature. And even I have combined these two, because now I have separated the magnitude and phase component different. So together what I am getting, when I combine these two, I am getting the again improved 17.4. It 19, I am getting up to 17.48%. So in that way, as compared to I have just justified instead of using raw LP residual signal, I am benefiting more by dividing the magnitude and phase component by processing the magnitude and phase component of the LP residual signal using analytical LP residual signal, and we are getting the better results. So 17.48. Finally, RMFCC plus MFCC I already told. Now what I have done, okay, we can again fused with the speech-based feature like MFCC and CQCC. And in the last slide, we are getting the result like 9.50 minimum. I get more result is reduced more good. I think it is like almost 2% improvement I am getting in the result. So result is improved up to 8.86%. So from this, we conclude that processing LP residual based Hilbert envelope and residual force information is more useful rather than direct processing of LP residual for detecting replay attack. So now from here, I can suggest the audience ki maybe they can analyze these features also, like LP residual and analytical Hilbert envelope and residual phase component. I have used the male representation. Maybe people you can use the other representation, other representations also, like they can go for constant Q septal analysis, or maybe they can go for some wavelength transform technique. So might be the improvement may be much more, and maybe remarkable improvement will come. So, but means like the motto is that definitely LP residual can be there is not a very limited exploration, but wide exploration may help that LP residual component also will have a good result, and when combined with the speech-based feature, definitely they will achieve the generalization, and we can get the generalization towards replay attacks, because we can. So in that way, I am going to the next slide. Now, till now, whatever I have discussed, that is the they are the means LP residual is the representation of the excitation for feature in implicit form. That is implicit form, means like that is not the hidden form. So I have gone through the some explicit form of the excitation source feature. So pitch and epoch strength. Pitch means fundamental frequency, and epoch strength, they are the explicit form. They directly represent the epoch features. So I have seen, I have calculated, I have using zero band filtering method I have used to compute the pitch and epoch strength, and then I make a feature. I concatenate them and I make a feature which is referred as PES feature, pitch and epoch strength feature. To that is, but dimension is very less, only 2. So, but I have seen when I have gone through the, if you will follow this figure, you have seen figure 6 distribution of the F naught and SOE estimated from the actual and corresponding replay speech selected, and I have selected the standard data set only. The samples are selected from the standard data set of 17. So what I have seen that there is a big difference. And this difference is showing between the actual and replay speech signal. Pitch and epoch strength can also be useful if we can explore in a maybe we can, if we know we able to capture which signal processing method will be good, or maybe through rigorous hidden trial method, maybe we can get the better results also. For me, I have just calculated the two 6-dimensional feature, two feature. 2 dimension is F naught and SOA, and then their delta and delta delta. So in total 6-dimensional PES features, and I have just computed the result. So result is worse. Definitely dimension is very less, so maybe we will get the worst result only. But might be this is I have used the GMM classifier. Maybe other classifier can improve this result. And finally, again, I have seen the result by fusing them. Still, what I observed that still very less dimension, but it has the capability of the complementary information. Means suppose for PES plus MFCC, PES plus CQCC, I am getting 10.34, and here for RMFCC plus CQCC, RMFCC of 57 dimensional feature, 9.50. So result means like it is very close to that. It's coming to close almost. It means that definitely they are representing, then they are the explicit form of the LP residual signal. So that people can exploit this one also. For this, I have taken the 20 millisecond duration only to compute this one, and 10 millisecond overlap. Maybe supra-segmental and sub-segmental, I did not go that analysis of the speech. Maybe that analysis will give the better PES feature representation, and might be the result will be improved more and close to somewhat more close to result might be improved on that. So maybe if some audience, if they are working in the speech signal, they can go for the supra-segmental or sub-segmental analysis of this one also. So in that way, now definitely, if I am talking about the pitch and epic, means like explicit excitation source information, definitely glottal flow derivative signal parameterization is also very important. So GFD signal represents this is the glottal flow derivative. Means like air pulse pass through glottis. So glottal flow derivative signal represent the complete excitation source information. Selection of, but for GFD estimation, we have to select the suitable method which will work for the replay detection SARS. There are so many available methods are there, like CDRIMS, ZFF, zero frequency filter, DIPSA method, YAGA method, DPI, and IAIF method available in the literature. Methods with the blue color text has been tested on ASB Spook 2017 database in some work like 30, and GFD signal where DIPSA method approach shows superior performance in that work. However, all blue color text methods are indirect method of computing GFD signal, where IAIF method is direct method of the GFD signal, estimated using LPC analysis and invert filtering via iterative manner. Thus, what I have done, I have used this method only for my experimentation purpose. Just I want to show one have a look on this temporal diamond representation of the actual and replay speech signal and corresponding IAIF method, IAIF method based GFD signal, extracted GFD signal from this signal. So what we can see that there is definitely a huge difference. There is a difference, obvious difference we are seeing between the actual and replay. So definitely this difference can be a key point. If we can able to capture and model these differences, that will help us to create a good countermeasure system. So again, I have go with the traditional male septal parameterization only to just check the initial level what exactly the performance is coming with the basic traditional methods using short-term system analysis. So what I have seen, along with the LP residual signal, pitch and epoch strength feature, GMFCC means glottal flow derivative is actually giving the better results of 16.06. Is the good result I get as compared to the 20 I am getting for RMFCC and 29 for PES and other features. And also when I have combined, I have seen that finally still I get the improvement from 8.86 is the better result, whatever result is coming. Now I further reduce that result 8.30. So in that way, I think that maybe GMFCC can, now if we can explore GMFCC, I have explored, maybe someone can explore some alternative signal using some alternative signal processing for glottal flow derivative signal. Maybe he will get more improvement, maybe up to 7, 6 or 6.40 like highest reported available, 6.40 highest reported available. That maybe also they can bypass those results also, and generalization might be also come into picture, because this is the pure complete representation of the explicit representation of the excitation source feature. So summary, I just wanted to summarize my work. So ASB systems and the ASB systems are good but advanced but vulnerable in presence of spoofing attacks. and need to be addressed. Prior work related to replay detection and current issues has been discussed in this work, and statistical analysis of the effect of the playback device response in replay signal we have seen. Method of processing LP residual signal for detection of replay signals we have seen. Method of processing LP residual amplitude and phase information separately in terms of excitation source feature for detection of relay signal we have explored. Method of processing pitch and epoch strength information together for replay pitch detection. Method of processing glottal flow derivative signal for detection of replay signal. So this thing we have explored, we have seen whatever that key. What I just wanted to suggest that key LB residual or maybe in the form of excitation source feature or glottal flow derivative, even pitch and epoch question, they can be they can be used they can be uh, used for the enhancement of the speech-based speech detection system, because definitely they will provide not only they will help the speech-based feature, they will also going to make them robust against unknown attacks from future perspective. So maybe some future research direction I have written. There are other people, some of the futures I just discussed in the while I am just going with the slide. Some future direction people can maybe explore for GFD signal, because finally GFD signal is the giving a better result. So maybe people can explore the glottal flow derivative signal in the form of fine and coarse structure. GFD quotient parameter like open close quotient, GFD signal with alternative signal processing tool, exploring excitation source information. Maybe someone go through the suppose another type of direction, because what is the effect of the noise, because whenever we have the security system, or maybe if we are using in publicly like public assessment with somewhere, then definitely noise will be there always in the market area and something. So maybe noise in detection of the replay detection system performance studies in case of noisy environment can also people go through one research direction. So these are the references are there, some of them, and I acknowledge the organizer of this one, this workshop, which conducted and invited me, and I acknowledge my NIT Nagaland for the giving the good research facility and to do conduct research here. And I acknowledge my PhD students and for giving their valuable contributions. And thank you very much. With I am just concluding my talk. Thank you all for listening and keeping patience for my presentation. So, if any question, I am here to.
Thank you, sir. So, student having some queries, how they will start to implementing the things. Some of the students have written me. So, can you
Uh,
guide them?
so,
Because many
for his,
beginners are there, many beginner students are there. So, from where they will
yes, yes.
start? So, just
So, for starting the means like research in speech signal processing, maybe now see many things are available in the net now. People are not means every facility with you. So, just you start with the basic program. Means like first of all, you just go through some introductory. Maybe upcoming sessions you will go with the speaker verification fundamentals also. So you just start with the speaker verification fundamentals and how the speaker verification takes place with some small level of program. Yeah, maybe I can also help you on that one to give some small program, and you can run it on the system and you can get some feel how the speaker is recognizing, how EER is coming, how the performance is going to improve and something like that. And after that, because ESB system and replay at a countermeasure system, they are complementary to each other. Means like ASB systems are existing, that's why countermeasure come into picture. So for that, if suppose you want to develop for the replay attack, because replay attack people are not now people are focusing more on audio deepfake, but still I am thinking anyway, because layman can also do something. So maybe this research should also be a very good only, in the literature if we can go through. So maybe if the students are asking, they can go for fundamental aspect of the speaker verification first, and they can start with some little program, speaker verification performance may be available in the GitHub. Google GitHubs are available now. Anywhere you will get the program in Python coding in the form of Python, and you just run and fill it, and then definitely automatically you will know the way how to proceed with the replay attack, or maybe other type of spoofing attack, or maybe for audio defect. And whatever database like ASP.Proof 2017 I am telling, those are available in the internet. Means everyone can go through and available, they can download the database because it is publicly available. Even 19 database also you can go through. And if there is help with Satyaranjan sir, my means like every email ID and everything is there. Maybe you can contact me also. I can help you as per if you are stuck somewhere in doing the research on that.
If anybody really interested, just start the fundamental things. Then you can directly connect with Madhusudan sir, or through me also you can connect. Okay, so that from the beginning we can start something. Try to download some tools, what other tools are required. Okay, from the GitHub, try to find out the basic course. Right, on the small programs, then only we'll go to the next level. And many faculties are joined from many schools. You can also take the help of them, him or her, and we can collaboratively we can start someone. Any other question from anyone? Yes. You can unmute yourself. Now you can unmute yourself and you can ask if any questions are there. Otherwise, you can stop here. So next session will be at 12 p.m. By Dr. Priyanku Sharma, who is the professor and head of the Humanities and Social Sciences of IIT Guwahati. So he is going to tell the specialization. He is having specialization in phonetics and phonology. So fundamental things he is going to tell from where you can start, because he is not from the background of technical. He is from humanities and social science. So he will tell you the fundamental things of the speech processing. So kindly join at 12 o'clock. Okay. And I will share all the whole schedule with you now. So thank you very much, Madhusudan sir. So
okay, sir. Thank you.
Contact any of the students or faculties. Yes, somebody wants to ask some question. Yes. If anyone asks some question, you can. Okay, I don't think.
It's okay, no problem. Suppose if you are not asking this time, still you can have a chance. You can get the email IDs and something. Even I am working in Nagaland, so maybe website also you can get my email ID and you can ask the doubts, or maybe if you want to start the research in the Om Prakash sir.
अरे मधुसूदन कैसे हो भाई? गुड मॉर्निंग।
ठीक हो सर?
पहचान लिया?
हाँ सर, पहचान लिया। जैसे ही आप आए पहचान लिया सर।
अच्छा। और बाकी सब ठीक ठाक है?
हाँ ठीक है सर। आप तो सर निकल गए, मैं तो यहीं रह गया।
हाँ कोई दिक्कत नहीं, और बाकी सब ठीक है। कभी मिलते हैं, फिर आओ इधर कभी।
हाँ सर, आएंगे सर जरूर।
डेफिनेटली
सर, सत्यरंजन सर। हाँ, नंबर
वही है, चेंज हुआ नहीं? ओके।
नहीं सर, नंबर तो शायद वही है। अदरवाइज सत्यरंजन सर हैज माय नंबर सर, व्हाट्सएप नंबर यू कैन जस्ट।
Om Prakash sir, are you here in our institute?
Yes.
Okay, fine. In computer science, sir. So you can come visit to campus 15A. Huh? We can meet. You can come.
Okay sir, thank you sir.
Thank you very much.
Thank you for inviting sir.
Okay, thank you.
Okay.
और मधुसूदन बाकी सब ठीक है? ओके बाय सर।
कौन सर आप लोगों को सागर दिखाई देगी? जाओ, this is a platform to connect each other.
ओ सर
ठीक है सर, थैंक यू।
हाँ सर। हाँ
कौन सर?
थैंक यू।